guys, welcome to my channel. Today I'm going to solve this problem directed graph cycle. So as it is marked medium and the code is also looking very complex, but no need to worry because as you all get to know about like how to approach this problem, then the code will be like cakewalk for you all. So you just have to bear with me till the end. So now let's read like how to approach this problem. Given a directed graph with V vertices and E edges, check whether it contains cycle or not. Question is just self-explanatory that we have to find that in a directed graph we can detect a cycle or not. Like if there is a cycle, then we have to detect it. 3. Okay, and there is one more edge coming to this. So before solving this problem, let me give you a brief like glimpse of how we have approached this same problem like cycle detection in undirected graph. So let me give you brief like glimpse how we have solved it. That okay, so here is the undirected graph. Then why am I explaining this? Because if you get to know now how we have approached this problem and like same concept would be applied here, but there is a slight difference. So what is the difference and why we come to know that, how we come to know that we have to change the code. So let's see. So we have you all can see that there is a cycle, but we have to detect it. So we'll be starting from 0th node. So we'll mark 0th node as visited, marked it as parent. We have two options, 1 or 2. Okay, so we'll be moving to 1. So we'll be moving to 1, marked it as visited and remove this as parent. Now 1 have how many options? 2 options. Go to 0 or go to 2. Let's say we move to 2. Okay, so for 2 this is the parent and we move to 2, marked it as visited. Now 2 have two options, this as 1 and this as 0. Now 2 will check that 2 have two options. So let's say we are moving to 1. Now just listen it carefully. If we move to 1, we check that 1 is already visited. So if we get a node that is already visited, we will check the second condition, that whether it is a parent or not. If it is a parent, then we will be skipping that node, will not like further move towards that node. Okay, so we'll be going to 0. Now parent is this, 2 is the parent. Now we'll move to 0th node. We'll check 0th node is already visited, then it is in danger. So we'll check the second condition, that whether it is the parent or not. So it is not the parent and it is already visited, then there must be a cycle. So let me write you the steps. So if node not visited, then explore it. Second condition is if node is visited, if node is visited, then check two conditions, whether the node which is visited is parent or not. If it is parent, not parent, if it is parent, then you can directly return true, that there is a cycle in this. If not, then we'll further like will not visit, like will be if it is parent, then okay, mistakenly write that. If it is parent, then we'll be skipping, and if it is not parent, then true, that there is a cycle present in the graph. So the same way we are going to solve this problem. So we are standing at node 0. So how do we approach this? We'll mark it as visited, we'll be moving to 1, this as parent. Okay, now from 1 we'll be marking it as visited. Now this is the parent, we move to 2. Now we'll mark 2 as visited. Now 2 is the parent and we'll be moving to 3. Okay, we'll move to 3. Now 3, mark 3 as visited, 3 is the parent. Now we'll again move to 3, we'll check that it is visited and it is parent. it is visited and it is parent, so we will skip that node. If we'll skip that node, then afterwards we'll return that false, that there is no cycle. But here is cycle present in this loop, so we can't identify with the previous approach. So how we are solving this problem? So let me give you one more simple example. Okay. Okay, so let me give you one more simple example. 1 2 3, this. So we have started from here, we have started from 1. Okay, we marked it as visited, and we'll be moving to this. This is the parent, and we'll mark 2 as visited. Now, so what we'll be doing, it marked is marked 2 as visited. This is the parent. Now 2 has no other options to move, so we will exit that path. Now coming to 3, by visiting 3, this is the parent, this is visited, like this is visited and it is not the parent. Okay, so we will be returning true. Like as you all can see that this condition from starting from 3, because we have explored this one. Okay, now we are exploring this 3. So what we have done is, we started from 3, we will be going to 2, this is parent, we'll check that okay 2 is visited and 2 is not the parent, then we'll return that this is the cycle, means true here. But here is no cycle. So now let's come to original approach. How are we going to solve this? Like from moving to this, while we move to 1, what we will do, we will maintain an extra vector in recursion or current recursion. So we will mark current recursion visited also, we mark, but current recursion is also true. Now as soon as we move to this, we'll mark it as visited, we'll mark current recursion as true. Now there is no path, so while returning to this, we'll be removing in recursion. Okay, now we'll moving to this, we'll remove that in recursion or current recursion. So after coming to this, exploring from 3, we will check that if it is visited, there is no concept of parent we are checking, so we will check that if it is visited and if it is present in current recursion, then there is a cycle. So let me like conclude it. So in directed, what we are checking is if visited and current recursion, if the node is visited and it is present in current recursion, directly mark true that there is a cycle, else explore another path, explore. And same what we are doing in undirected. Undirected, we are checking if visited is true and not parent, then return true that there is a cycle, else explore. So let's see the code now. I hope this is clear. So let's see the code. So what I have done is, I have made a vector of current recursion, marked initially all the elements of that current recursion as false, made a vector visited, element of that visited is number of elements is v, and initially marked all at as 0. Now moving, why I'm doing this for loop? Why? Because for this case, like if I'll be exploring from 1 only, like from 1 only, then I would have explored this path only. So what about this, how to explore this? So that's why I have made a for loop to like check whether 0 is visited, and inside it I am like I have put one more condition, that if it is not visited, then only explore. Like in this condition, 0 1 1 2 and 3. Okay, so 1 2 3, 1 I have visited, 2 I have visited, 3 is not visited, then explore the path. Okay, so this is the way it is working. So if solve like this current recursion, if it runs and came with the solution that there is a cycle, then we will be returning that return true, that there is a cycle in this, else return false. Now we'll be coming to the recursion part. while like mentioning the solve function, we have passed 0, sorry, u means I, current 0. So it will be exploring u, adjacency list, current recursion, and visited. Marked visited as true because whenever we move to one path, from one path to another path, okay, from this to this, we'll mark it as true, we'll mark it as true. Okay, so marked as true, and in current recursion also true. Now we will be exploring that from u, adjacency of u, where are all the options which we can visit. So as I have told you that we have to check two conditions. If visited of v is true and current recursion is also true, then we will directly return true, that there is a cycle. Else if visited it false, means this node is not visited, then we will be exploring all other options. We have passed here v, note that we have passed here v, because from u we can move to v, and we have passed v, like go and explore the path v. And if it comes with a solution that, like, okay, so let me tell you with like this. So how this like recursion is going call, from this part, from this part, okay, from this part it will again move to this call, okay, again move to this call. And if at any point while going to this path it gets true, then it will return, means while returning to this it will return that true. Okay, we have got that there is a cycle. It has already marked true, means this visited has already marked true, then only we have explored. So this is already true and this also becomes true, then there is a cycle, will be directly returning true. Else if it is not the case, then we, after returning from the for loop, this for loop, we will come like after the for loop and marked in recursion or current recursion as false, and finally we return false, like after, okay, like in this this part, after going to this, while coming back to this, we have removed the ith part, like current recursion is false. So that only we are doing in this part, and finally the answer is false. And this way we are going to solve this directed graph cycle. So I hope this is clear, and so thank you for watching.